I've just released a scenario editor for Tornado Research and Rescue, and I'm going to show how to use it. So the first thing you'll have to do is find where the scenario files are. So inside Steam, right-click on the game, go Manage, and then Browse Local Files. You'll then need to go inside TRR Rebuild, Tornado Research and Rescue Data, Streaming Assets, Scenarios, and then that's how you get there. So inside the Twister Research and Rescue folder, TRR Rebuild, Tornado Research and Rescue Data, Streaming Assets, Scenarios. Eventually I will have an in-game editor, but for now, this is the process you'll have to go through. So I've already got a sample scenario there for the Bridge Creek Moa tornado of 1999. Let's create the Moa 2013 tornado. So we'll just copy and paste those files. I highly recommend having Notepad++ installed to edit the scenario file. So I'm going to just go through each of these fields. So format version, just keep that as one for now. As the game evolves and the scenarios get more complex, I may have different versions of these files, and this is just a way to distinguish that. The ID is just for your own reference, put what you want in there. The display name is the name of the scenario, so I'll say the Moa 2013 tornado. I'll just say historical tornado that tracked through Moa, Oklahoma in 2013. Then we're going to have to find a bit of information about this scenario. So the first is we need to get the latitude and longitude. Easiest way to do that is just go to that location in Google Maps, right click, and you can copy the coordinates there onto your clipboard. So if I replace this and then got the latitude there. And then we've got the UTC offset as well, which is the same. This just lets the game recreate the lighting as close as it was on that day, given the date and time. So the year for this scenario is 2013. It was still May. It was May 20th, I believe. Let me double check that. Yeah, May 20th, 2013. And the time it touched down. So if we used the Tornado Archive website, we can see the UTC time that it touched down. We need to subtract 5, so that'll be 1456. But we don't want the scenario to start exactly at the time the tornado touched down. So let's just say 1450, starting 6 minutes before the tornado touched down. Next thing we need is to know the width of the map. I'll show how to measure this in a minute. So set the map width to 30 kilometers. That'll be big enough for this. Require exact size, keep that as true, and road network, keep that as simple road network. There may be some features in the future which use these, but right now just keep them as is. Next is the player spawn location. This is based off the bottom left corner of the map. So I've just set it a kilometer in and a kilometer up from the bottom left corner of the map. Usually a good place for tornadoes that track southwest to northeast. Environment, use configured weather maps. Just keep this as true. Again, it's future proofing. Keep all these exactly as is. Don't change any of those or just break the scenario. ID, so this is the ID for the tornado. So again, we'll just say like Moa 2013. And then the display name, let's call it the Moa 2013 tornado. And the track file, you can name this what you want. I'll just keep it as tornado1.csv. And then we're going to choose whereabouts in the actual map the initial touchdown point is going to be. I've just set this to 500 meters by 500 meters, so a little bit closer to the corner of the map than the player. Touchdown delay minutes, this is how many minutes between the start of the scenario and when the tornado actually will touch down. Since we started it 6 minutes early, we can just use 6 there. These need a little bit more explanation. These describe the wind field of the tornado. So the fall-off factor is how quickly the winds weaken as you move away from the tornado. Higher numbers mean that that number falls off more quickly. The next is swirl ratio. This is how much the tornado rotates, or the winds around the funnel rotate, compared to winds flowing directly into the funnel. I've just kept those as 1 and 1 for now. The radius of max wind scale, so this is essentially deciding where are the strongest winds. So if this is set to 1, it's on the very outer edge of the visible funnel. 0.85 means it's 85% of the way between the center of the funnel and the visible edge of the funnel. So for the last scenario I did, 0.85 created the most realistic wind field compared to the actual real life recorded track. Last one we have here is trail jitter scale. I'd suggest keeping that as 0 for now. You can experiment with some values. All this does is add some random variations to the tornado track that's drawn on the map, just so it doesn't look like you've got perfectly straight lines. It makes it look a bit more organic and natural, like tornado paths look. You don't get these perfectly straight, smooth damage trails, and you have variations in there. So that's all that parameter controls. So now we've got the scenario JSON, we need to actually get the data we need to build the scenario. So again, I strongly recommend going to the Tornado Archive website. And then what you can do is type in the date for your event, use the filters to filter down to the exact tornado you want. You then click on Share and download KML. You can then open this in Google Earth. So I've already got this opened up, and this is how I determined the size of the map earlier. You click the ruler, and then let's just go like this here. You have to have a square map, and this is the longest dimension. So yeah, if we have a 30-kilometer map, this should be fine. So now we want to start recreating the actual scenario. So we need to edit the CSV file. For that, you can either use Microsoft Excel. I don't have a license for that. Another option is Google Sheets, but then you need to then like upload and download and convert to CSV. I've also just installed a CSV editor called Smooth CSV that's free. So I've got this here, so I'll just click and drag this into here, and I'll show how we can start creating the scenario. So what I'm going to do is I'm just going to delete all of this, and we'll start creating this. So I think what would be useful if I put this on the left-hand side and have Google Earth on the right-hand side. So the tool you're going to use for this is the ruler. So what we can do is just give an initial heading. So if you just click on your start point and click on your end point, and the heading is 54.71 degrees, so we can input that, 54.71. Have your distance set to kilometers, then it's going to track 5.12 kilometers. This will be the first leg. Speed will come back to speed at the end, and eventually it's going to touch down with 0 width, and once it gets to here, we reach a width of 460 meters. And then that's an intensity of F1. This is using the EF scale, we're using the F scale. For the sake of demonstration, it doesn't really matter. So I'll set the intensity to 1. Now this is where you can start being a bit more creative. The bottom ratio is how wide the bottom of the tornado is near the ground compared to the top of the tornado. So if I just open Paint, and I'm going to do some excellent hand drawings here. If you've got a tornado like this, and it's say a kilometer across here, so 1,000 meters, and it's 100 meters here, it's got a bottom ratio of 0.1, because if you divide the width at the bottom by the width at the top, you get a value of 0.1. So this is where you can be creative, so you can start cross-referencing actual footage and try and get something realistic. But I think to start off with, let's just stick something like 0.7 in there. You can also add a note, and this will be displayed in-game. So I'll just say initial touchdown of the Moa 2013 tornado. So each of these is going to be a leg essentially of the tornado, and then we'll continue to create these. So then the next leg, so we've got to this touchdown point here. So I'd say each leg is each time it changes heading quite significantly. So if we go from here to here, then now have a heading of, because we went from the initial point to here, so that gives a heading of about 55 degrees. And now we're on a heading of 33.9. So we can add 33.9 to that for a distance of 1.02 kilometers. And at this point, it is a width, so we can measure the width here. I know the damage trail doesn't correspond exactly to the width of the tornado, but it's a good ballpark for the game. Let me just do that. So it's 540 meters, and at this point, it's already going up to F1, F2. So it's already at F2 intensity by this point. We could change the bottom ratio, make it more stovepipe-like. I set it to 0.8. I'm going to leave the notes out for now because I don't recall the exact events which happen at each point. I'm just going to demonstrate how to do this. So we're up to this point here. And so every time the tornado strengthens or widens or changes direction, you're going to want to add a leg to the file. So let's continue on. So now it's heading more northeast, so at a heading of 47.73 for a distance of 0.28 kilometers, and we're already up to F4 strength with a width of what? 640 meters. And we can be a bit creative, kind of vary these numbers just so the funnel changes shape. And we can continue this process on. Let me just do a very rough one for demonstration purposes. So from this point here, it's hit F4 strength. So then let's just go up to here and say it weakened to F3 strength. So 55.5 and for a distance of 3.42. Weakened to F3. Let's set this to something like 0.6. And then it's reached a width at this point of about a mile. So let's just say 1.6 kilometers. Oh, sorry, 1,600 meters. All right, then we'll go to the point where it intensifies again. So this is a heading of 78.55 over a distance of 1.83 kilometers. Reaches a width of what here? 1,130 kilometers. Goes back to an intensity of F4. Let's make it more wedge-like. Let's say 0.85. Let's make sure I'm saving this. And then we'll do the main leg from, say, here to here. I know I'm just approximating it just now. This is just to demonstrate how to edit these things for the game. So heading of 73.62, map length 6.91 kilometers. And this point it weakened back down to F3 did. Oh no, that's actually where we reached peak intensity of F5. So we'll set the intensity to F5 and roughly what's the width of the funnel here? Damage path 650 meters, so put that in. I'd say like 0.9, make it like more of a stovepipe at this point. And then what we can do, let's add just a few more legs. So from here to here, say 2 kilometers, so heading of 92.92, 2.07 kilometers, width of what? 530 meters, and it looks like it's dropped to, let's say about F4 strength there. Let's say 0.6, make it more of a cone at this point. And then we can just do like the final leg, something like that. And we're going to say heading of 81.08 for 6.61 kilometers. And then it's going to rope out. So let's just set a target width of 0 and an intensity of 0 and a bottom ratio of, let's just say 0.3 for this leg. Actually, let's make it more wedge-like, 0.75. So as you can see, I just very roughly approximated this for the video, but you get the idea. If you want to go in and add dozens of legs, you can. One thing you can even do is feed the KML file to something like ChatGPT or some other LLM and say, create a tornado path file, give it a CSV file, show it the CSV format, say take this KML and create a scenario. It can usually do a pretty good job of that. If you want to cross-reference footage and get this ratio correct and like the width correct, you can do that. The last thing to do is the speed. Since it's usually really hard to get exact tornado wind speed, what I do is look at the start time and end time of the tornado. So let's just have a look on here. It says start time. Does this give you the end time? It doesn't, but I don't know if that really matters for this demo. But what I do is I'll just divide the total distance, so we can see the total distance it's covered here. So I'll divide that distance by the time to get the speed. And let's just put in 25 miles an hour. We can just vary it a little bit. Okay. So we've got that, and then we'll just say rope out phase. So we've got all that. The next thing to do is actually fire up the game. So we can go to scenarios, and then we can see the Moa 2013 tornado. Heading is not a number. So I guess this shows how to debug. At line 10 it says heading is not a number, so I must have input something incorrectly here. So let's go and fix it. So I'll tab out of that, see what we did incorrectly there. So I wasn't planning this, but this gives us a good chance to debug things. Oh, we've got, there we go. So it may be worthwhile checking this in a text editor. The problem is that we had these blank entries, so let's just save that. And this should probably be in quotes as well. This is add empty quotes on each of those rows just to be safe. We shouldn't have to quit the game if we refresh. There we go. So you can use time compression here. To check the scenario, I'd say go to preview. All that'll do is replay the scenario at 40 times speed, just so you can check that the trail looks correct. And check everything works correctly with the scenario as planned. Okay, so if we open this, we can right click and check we're spawning at the right time. Yeah, so 14:56 the tornado should start touching down. We've got our prompt there, initial touchdown of the Moa 2013 tornado. We can see it moving along the map there. Have a look out, we should be able to see it as well. So all it'll do is follow each segment of the CSV file and you'll see it replay. Then we're in the rope out phase and you'll see it eventually fade and disappear, and then that'll be the scenario completed. So you can see we've got our trail there and how it corresponds to our map and our CSV file. So that's everything you need to know to start creating scenarios. Like I say, I suggest going to the CSV file. Once you've created it in an editor, just check you don't have any blank lines or anything trailing. Make sure each of these are in quotes, just to make sure that all the formatting and everything's correct. And then, yeah, enjoy, see what you can create. I look forward to seeing what people add to the game. I'm going to add Steam Workshop support to this as soon as I can, so that way you can just subscribe to them on the Steam page and they'll automatically be downloaded into your game. So thank you for watching. If you have any questions, put them in the comments section or join the Discord, and then you can ask me directly as well, or join any of the live streams. I'm always answering questions there as well. So I'll see you all in the next stream or next video that I make.